SpaceX just painted part of a heat shield it's spent years perfecting, white. 18,000 black tiles cover Starship, flight tested, proven. And days before Flight 13, a handful near the nose changed color with zero explanation. One story says it's just paint, a tracking marker for 6 cameras watching from orbit. Another says it's the first sign of an entirely new tile. Stronger, built for something bigger than this flight. The real answer is stranger than either one. Here's what's really going on. Let's start with what was actually seen. Not rumor, not a leak. Photographs taken inside Star Factory in early July. A technician is installing heat shield tiles on a Starship nose cone. Routine work, the kind SpaceX does every week. And then, right near the very tip, the pattern breaks. The familiar black hexagons stop. In their place, white ones. Same shape, same rough thickness. Installed the same careful way, tile, by hand. These are not shipping covers. They're not protective film for transport. Look at the finish. Smooth, precision cut, mounted with the same structural care as every other tile on this rocket. These are flight hardware. And here's the detail that should stop you. This isn't the first time white tiles have shown up. Hints surfaced earlier this year, briefly, without enough evidence to mean anything. This time, the picture's different. This time, there's a pattern. Which means someone at SpaceX made a deliberate decision. And now we get to figure out why. The first clue, size. Look closely at these white tiles and one thing jumps out immediately. They're smaller than the black ones. Not by a lot. But in aerospace engineering, not by a lot is often exactly the point. Here's the mechanic behind it. Every tile on Starship sits next to its neighbors with a small gap, a seam. During re-entry, when the vehicle is punching through the atmosphere at several times the speed of sound, superheated plasma is constantly hunting for those seams. Any gap is a weak point. Smaller tiles mean more seams overall, but each individual seam is narrower, and narrower seams are harder for plasma to exploit. The heat load also spreads more evenly across more tiles instead of concentrating stress on a few large ones. It sounds like a small tweak. It isn't. It's the kind of refinement that shows up after real flight data. After SpaceX has watched exactly where plasma intrusion happens on a returning vehicle and decided to engineer that weakness away, tile by tile. So the size isn't decoration. It's a response to a problem space has already seen. What problem? We'll get there. This is where it gets more interesting. Current Starship tiles don't work alone. Underneath the visible ceramic hexagon, there's usually a layered backing, a kind of insurance policy. If the top tile cracks or burns through, that backing layer is there to absorb heat and protect the steel skin of the rocket. The white tiles appear to skip some of that backing. Think about what that implies. Either the tile material itself has gotten strong enough that it doesn't need a backup layer anymore, which would mean a new ceramic formulation, possibly a completely different composition than anything flown before. Or SpaceX has found a way to simplify the whole stack without giving up protection. Either way, fewer layers means less weight, faster installation, and, critically, faster turnaround between flights. And turnaround is the entire point of Starship. Remember, this isn't a vehicle designed to be recovered and rebuilt over months, the way the space shuttle was. The goal, stated by SpaceX from day one, is land, inspect, refuel, launch again. Every gram removed from the heat shield, every hour shaved off installation, is a direct step toward that goal. If these tiles really do simplify the protection stack, this isn't cosmetic. This is SpaceX chasing rapid reuse, one tile at a time. But notice something. We still don't know what's driving this. A new material, or just a simpler design? That's the same question this video opened with. Keep it in mind. The answer isn't what you'd expect. Why the nose? Why now? Location matters as much as material. These white tiles aren't scattered randomly across the vehicle. They're concentrated at the very tip of the nose cone, one of the most brutal thermal environments Starship experiences during re-entry. That location isn't an accident either. The forward header tank sits right behind that nose section. That tank holds propellant needed for the final landing burn. If heat ever breached the structure there, the consequences wouldn't be minor. They'd be mission-ending. So if SpaceX is going to test a new heat shield concept anywhere first, the nose is exactly where you'd expect them to start. Protect the part that can least afford to fail. There's also a structural change worth noting. This section appears to rely mainly on mechanical attachment pins, rather than the mix of adhesive and fasteners used in earlier tile generations. Adhesives degrade. They're vulnerable to repeated thermal cycling, heating up on ascent and re-entry, cooling down on the ground over and over, flight after flight. Mechanical pins don't have that fatigue problem in the same way. If SpaceX is serious about flying these vehicles dozens, even hundreds of times, betting less on glue and more on hardware is a rational move. So where does that leave us? Smaller tiles, possibly no backup layer, mechanical attachment, all concentrated at the one point on this vehicle where a single failure ends the mission. That's not a random experiment. That's a targeted fix. Now, has SpaceX had a vulnerability there before? Yes, and the story behind it goes back further than you might think. To understand why this tile change matters, you need to understand what SpaceX has already been through with this heat shield, because this isn't SpaceX's first attempt to fix a weakness. It's their fourth or fifth. Go back to the earliest Starship test flights. The single biggest problem wasn't heat, it was vibration. Powerful shaking from the Raptor engines, combined with the stainless steel structure expanding and contracting under thermal stress, caused ceramic tiles to crack loose and fall off, sometimes mid-flight. Engineers spent months redesigning the attachment hardware, refining adhesives, and building more precise robotic installation systems just to keep tiles attached to the vehicle at all. Then came a second lesson, a harder one. Early ceramic formulations were too brittle. Under aerodynamic load, some tiles simply fractured. That forced SpaceX to slowly rework the chemistry of the ceramic itself, trying to make it tougher without losing its heat resistance. That's when the backup ablative layers appeared. The very layers the new white tiles seemed to be skipping. Engineers added them precisely because no single tile could be trusted alone. If the surface cracked, the ablative layer underneath would sacrifice itself, burning away to protect the steel structure beneath. It was survival through redundancy. Protect the failure, don't just prevent it. And then SpaceX tried something completely different. Metal. A fully metallic heat shield sounds appealing on paper. Metal isn't brittle the way ceramic is, and it pairs naturally with active cooling systems. SpaceX genuinely pursued this path, but reality pushed back hard. During flights 10 and 11, sections of the metallic shielding developed severe oxidation, that unmistakable orange discoloration many viewers noticed and asked about at the time. Oxidized metal is harder to refurbish and less predictable under repeated stress. The dream of a metal shield didn't die completely, but it stalled, and SpaceX shifted its focus back to refining ceramic instead. One more fix deserves mention, something engineers nicknamed the crunch wrap. Even the tiniest gap between two tiles can let plasma sneak underneath the surface during re-entry. The crunch wrap fills those gaps with a specialized insulating material, sealing the seams before heat has a chance to exploit them. Now zoom out. Tile loss, brittle ceramic, ablative backups, a metal detour that didn't pan out, seam sealing techniques. Across 12 flights, SpaceX has approached this heat shield the same way every single time. Test, fail, learn, rebuild, test again. The white tile isn't a new chapter in some separate story. It's the next page of a book SpaceX has been writing since Flight 1. So if history is the guide, this white tile isn't the finish line. It's the next hypothesis. And hypotheses get tested soon. Who's actually waiting on this? Timing matters here, and this is why. Right now, S-42 is the newest Starship vehicle moving through assembly. Based on where this photographed nose cone sits in production, the white tile hardware likely belongs to S-43, or possibly S-44. Vehicles that haven't flown yet, but are close. That timeline lines up with something bigger. S-42 exists to validate improvements introduced after Flight 12. The vehicles coming after it are being built to push Starship closer to consistent orbital re-entry. And once re-entry becomes routine, the next objective is obvious: bring the ship back in one piece and land it. If SpaceX is serious about attempting an actual Starship landing in the near future, upgrading the heat shield now, ahead of that milestone, is exactly the move you'd expect from a company that tests before it commits. And this isn't just about the vehicles flying between Texas and the ocean. Think about Starship HLS, the lunar lander variant NASA is counting on for Artemis. Today, HLS doesn't need a traditional heat shield because it isn't designed to return through Earth's atmosphere on its early missions. Carrying thousands of thermal tiles would just be dead weight for a vehicle that never re-enters. But today is doing a lot of work in that sentence. If SpaceX and NASA ever build toward permanent lunar infrastructure, regular trips between the moon, orbiting stations, and eventually Mars, reusability stops being optional for those vehicles too. A lunar shuttle that gets thrown away after one trip doesn't scale. A lunar shuttle that lands, gets inspected, and flies again does. And any vehicle designed for that kind of repeated use, especially one carrying people, needs dependable thermal protection somewhere in its future. Today's white tile test on an Earth return Starship could end up being one of the earliest building blocks for a heat shield HLS doesn't need yet, but might need eventually. So who's really waiting on this small white tile? Not just the engineers at Starbase, NASA's Artemis timeline, the first crewed lunar landing this decade, and further out, whatever comes after that, permanent lunar bases, and the infrastructure Mars will eventually demand. A lot rides on 18,000 ceramic hexagons doing their job correctly. Which brings us to the part of this story that the internet got wrong. The twist, what SpaceX actually confirmed. Remember the two competing explanations from the start of this video? One said the white tiles were the first sign of a completely new ceramic, stronger, lighter, engineered for the future of reusability. The other said something far simpler, paint. Here's what's actually been confirmed, and it changes the shape of this entire story. Flight 13 is scheduled to fly Starship Ship 40 alongside Super Heavy Booster 20. As part of that mission, 20 next-generation Starlink satellites will be deployed, and 6 of them have been fitted with camera systems specifically built to photograph Starship's heat shield during flight and beam that imagery back to engineers on the ground. Several tiles on Ship 40 have been painted white for exactly this reason, to act as visual targets, high-contrast markers that make it dramatically easier for orbital cameras to track tile condition, movement, and damage in real time. In other words, at least some of what you're seeing in those Star Factory photos isn't a new material at all. It's paint, a tracking tool, a way for SpaceX to finally get clear, trackable imagery of how the heat shield behaves during the most violent seconds of the mission, instead of guessing from telemetry and post-flight inspection alone. Does that mean the new material theory was wrong? Not necessarily. And this is the part worth sitting with. SpaceX isn't only testing paint on this vehicle. The same flight includes upgraded tile designs on the aft flaps, modified tile attachments around the aft skirt, and load-sensing tiles built to measure structural stress directly during flight. Multiple experiments, multiple hypotheses, running in parallel on the same rocket in the same mission. So what's the real answer to the mystery this video opened with? It's not one explanation or the other. It's both, happening at once on different parts of the same vehicle. Some white tiles are simply paint, doing a job as simple as marking a target. Other changes nearby, the smaller size, the missing backup layer, the mechanical pins, may still represent genuine material and design evolution, tested in the same window because SpaceX doesn't waste a single flight on just one experiment. That's not a contradiction. That's how modern rocket engineering actually works. Stacking as many test objectives as possible onto every single flight, because flight test data is the most valuable resource SpaceX has. The flight that will prove it.
So what is Flight 13 set out to do? It's a repeat of the profile SpaceX flew on Flight 12, and there's a clear reason why. On May 22nd, Flight 12 marked the debut of the new Starship 5-3 vehicles, a real milestone, but it didn't go entirely to plan. Ship 39 suffered an engine-out event during ascent, which stopped it from completing a planned in-space engine relight. Meanwhile, Booster 19 failed to properly execute its boost back burn, and instead of returning to the launch tower for a catch, it splashed down in the Gulf of Mexico. The upper stage proved the new V3 design works. The booster still needs work before SpaceX risks a catch attempt. So instead of pushing toward a full orbital profile, Flight 13 repeats the suborbital trajectory, a deliberate conservative choice. Booster 20 will attempt its own boost back burn and a water landing, this time aiming to prove the fix actually works. Ship 40 will attempt a single Raptor engine relight in space, deploy those 20 Starlink satellites, including the 6 camera-equipped ones watching the heat shield, and then attempt a controlled descent and splashdown in the Indian Ocean. No tower catch this time. That milestone is being saved for Flight 14 once the booster's reliability has been proven here first. Notice the pattern. This is the same philosophy that built the heat shield itself. Tile loss, brittle ceramic, ablative backups, a metal detour, seam sealing, and now painted tracking markers plus quiet material experiments, all stacked on one mission. SpaceX doesn't wait for perfect data. It flies, watches what breaks or what works, and adjusts before the next flight. Flight 13 isn't a moonshot. It's a checkpoint, designed to confirm the fixes from Flight 12 actually hold, while quietly gathering the imagery and stress data that will shape whatever heat shield eventually attempts a real landing.
Why this actually works in SpaceX's favor.
This is the part worth appreciating because it's easy to read all of this as chaos, engine failures, splashdowns instead of catches, competing theories about a handful of white tiles, and assume something is going wrong. It isn't. Look at what's really happening underneath the noise. A company is flying repeated, deliberately conservative missions specifically to isolate variables before stacking risk on top of risk. They're not hiding the Flight 12 failures. They're building the next flight directly around fixing them. They're not guessing about heat shield performance. They're putting cameras in orbit to watch it happen in real time. And they're not committing to one heat shield theory. They're running multiple experiments simultaneously so that whichever approach actually performs best in the real world is the one that survives. That's not the behavior of a program flailing for answers. That's the behavior of a program that has learned, tile by tile, flight by flight, exactly how expensive it is to guess wrong at Mach 20. Every scar in that heat shield's history, the lost tiles, the brittle ceramic, the oxidized metal, pushed SpaceX toward exactly this kind of layered, camera-verified, multi-hypothesis testing. The white tile isn't proof of a problem, it's proof of a process that's finally mature enough to stop guessing. And that process is aimed at something much bigger than one rocket. Every piece of camera data pulled from Flight 13's heat shield, every stress reading from those load-sensing tiles, every lesson from a booster that's now landing on water instead of catching the tower, all of it feeds forward. Into Flight 14's catch attempt, into the orbital missions after that, into the first real Starship landing. And eventually, if the timeline holds, into a lunar lander that might one day need exactly this kind of thermal protection to keep flying between the Earth, the Moon, and whatever comes after that. A handful of white tiles, photographed almost by accident inside a Texas assembly building, turned out to be a window into all of it. The failures that built this heat shield, the cameras now watching it fly, and the landing SpaceX has been chasing since the very first flight. That's the engineering behind the white tile. Not hype, just data. Thanks for breaking it down with me. Like, comment, share, subscribe to the Space Brief. More is waiting right there on screen.